Hello everyone and welcome to this presentation on API Gateway and Service Mesh, key components in modern system design. In today's session, we will explore the core concepts, responsibilities, and key features of these two important components in building scalable and secure microservice architectures. Let's take a look at the agenda for today. First, we will introduce the concept of API Gateway and discuss its responsibilities. Then we will move on to service mesh, dividing it to its core features. We will also compare API gateway and service mesh, explore best practices for each, and conclude with a summary of their roles in modern system design. An API gateway is a server that acts as an entry point for clients to access various backend services. It handles traffic routing, authentication, and other responsibilities such as caching and rate limiting. Think of it as a traffic controller managing how requests flow from external clients to the right services within our system. Now let's dive into the key features of an API gateway. First, it routes incoming requests to the correct backend services. It's also responsible for centralized authentication and authorization, ensuring that only authorized clients can access our services. Additionally, it can implement load balancing, distribute traffic, cache data, and enforce rate limiting to protect backend services. There are several popular API gateway tools available. Kong is an open source solution that offers plugins for traffic management and security. Nginx is a lightweight, high performance gateway that works well for web applications. AWS API Gateway is a fully managed service for building and deploying APIs, and Traffic is another modern HTTP reverse proxy focused on microservices. Now, let's turn our attention to Service Mesh. A service mesh is an infrastructure layer that manages service to service communication within a microservices architecture. Unlike the API gateway, which focuses on external traffic, a service mesh handles internal service communication, ensuring reliability, security, and observability. Some key features of a service mesh include service discovery, which automatically detects services and their instances. It also provides traffic management, ensuring that requests are routed appropriately. Load balancing, fault tolerance mechanisms like retries and circuit breaking, end-to-end security with manual TLS, and observability for tracking service interactions are all integral to a service mesh. Some widely used service mesh tools include Istio, which is feature rich and offers robust traffic management and observability. Linkard is another popular choice, known for its simplicity and lightweight architecture, and Consul by HashiCorp focuses on service discovery and configuration. Now let's compare API Gateway and Service Mesh. The table on this slide outlines some key differences between the two. API Gateway manages external traffic, including routing, security, and caching, while a Service Mesh focuses on managing internal service communication. Both play important roles but serve different purposes within a microservices architecture. To maximize the effectiveness of our API gateway, it's important to decouple concerns by using the API gateway solely for external communication. Ensure that it scales well with increasing traffic and implement strong security measures such as authentication and encryption. Finally, avoid overloading the API gateway with too many responsibilities, keeping it focused on its core tasks. Similarly, for service mesh best practices, ensure efficient traffic management by leveraging dynamic routing and traffic splitting. Always prioritize security with manual TLS. Make observability a priority by implementing robust logging and tracing. Enforce strict access control policies to ensure secure communication between services. In conclusion, both the API gateway and service mesh are crucial components in modern system design. The API gateway serves as the entry point for external client communication, while the service mesh handles internal service communication. Together, they ensure a secure, scalable, and efficient architecture for microservices. Thank you for your attention. I am now open to any questions you may have. Feel free to ask about API, gateway, service mesh, or any other related topics.